Hello everyone, my name is Shoaib Ahmed Abbasi, and today we're going to discuss about normalization. Um, if you have watched my previous video, I actually um, talked about briefly talked about normalization and different levels of normalization basically. So what normalization allows you to do is to basically reorganize your logical data dependencies and allows you to remove data redundancy, the data duplication. um, and it's quite important, in relational databases, because you design your databases based on the normalization principles. So normalization goes from from level 1 to all the way up to level 5. um, but as I mentioned in my last lecture, that I've not come across um, or not seen any examples where companies have actually gone beyond the third normal form. So let's get started, and let's discuss the first normal form. So the first normal form says that the attribute should only contain atomic values, so there should not be any multi-value attributes, and also there should not be any repeating values in your data structure. So if we look at here in this example, you can see that customer has multiple cities. Perhaps customer has different addresses, and those addresses are in different cities. And if you look at this customer city attribute, uh, the customer city attribute is a multi-value attribute. And what I mean by multi-value attribute is this attribute has multiple values. So it has London, Manchester, London, Bristol. And first normal form says that if you want your existing structures to conform to the first normal form, then you should not have any um, multi-value attributes. So if we were to actually convert this into the first normal form, the first thing we will do is we will break this down and we will create this as a separate table. So we will have customer ID and a city, and now you see that in the in a city attribute there are no multi-values. So there's only one London, there's Manchester, there's Bristol, but we don't have multi-value attributes. um, so for example, instead of city, if we had telephone numbers and customer can have multiple telephone numbers, then and that becomes a multi-value. If that becomes a multi-value attribute, so you have telephone number 1 comma telephone number 2, then if you want to convert that to first normal form, you would need to apply the same principle. Basically, you have to break that multi-value attribute down. And in order to remove the repeating values, you again basically break that relationship down, and you basically have and you basically remove the repeating group. So if you look at here, we have customer name and last name actually repeating multiple times, and they are actually repeating multiple times because of the address, because customer has multiple addresses. In order to remove that, we create a separate table, and here you see that we only have one David Miller associated with customer ID 10001, and only one Alice Cooper associated with customer ID 10002. Moving on to the second normal form. Second normal form basically says that your data structure should already be in the first normal form. If your data structure is not in the first normal form, then you cannot start upon the second normal form. The second thing that second normal form says is that all of your non-key attributes should be fully functional dependent on the primary key attributes. So So there are two terminologies here, key attributes and non-key attributes, that you really have to grasp and really have to understand. Um, if you don't already know what key attributes are, then to give you a quick introduction on key attributes are attributes that basically uniquely identifies a role. Um, you have many different types of key attributes. For example, you have primary key, you have candidate key, you have composite key attributes. And what second normal form says is all of your non-key attributes, though not the key attributes, non-key attributes should be fully function dependent on the primary key. Now if you look at this example here, um, um, store location is actually a non key attribute. So London Manchester is not exactly a key attribute, it's actually a non-key attribute, and it's dependent upon store ID. So London has store ID 1, Manchester has store ID 2. So a non-key attribute store location depends upon um, a primary key store ID. But in this example, it's also related to customer ID. Store location is only dependent on customer ID because of store ID, but store location and customer ID are not directly related. So second normal form says that we should break that down, and once we break that down, we have store ID and store location as a separate table, and once we do that, we have London and Manchester now fully functionally dependent on store ID 1 and store ID 2, um, and customer ID and store ID um, are created as a separate table. So that's the second normal form. So you remove the non-key attributes, find the dependency upon the non-key attributes, and make sure that they are fully functional dependent the um, on the primary key. Basically, this now becomes your becomes two separate tables. Um, Now moving on to the third normal form. In third normal form, your data should already be in the second normal form. That's the first criteria. If you want to convert your data into third normal form, it should already be in the second normal form, and there should not be any transitive functional dependency. Now, what is transitive functional dependency? A transitive functional dependency is basically a dependency where uh, A depends on B and B depends on C, and because B depends upon C, there is a relationship that A also depends upon C, but not directly. So if you look at this example here, we have product, we have category, um, and we have a price. Now, if you look at subcategory, subcategory is directly related to category ID, but subcategory is not directly related to product ID. It's related to product ID because of the category ID, but not directly related with product ID. Um, Product ID is a primary key, and product category ID is dependent upon product ID. So for example, product 601 refers to product one product can only be in one category, and you can identify a product category by a product ID. So product ID uniquely identifies a product category. So for example, you have mountain bikes, and mountain bikes, for mountain bikes you have product ID 601. So 601 will always be a mountain bike. um, um, so 601 will always come under the category 1, and 601 will always be a mountain bike, but category ID is also dependent upon subcategory ID. um, the point that I'm trying to make here is, although it seems that subcategory and product category are actually related, and they are actually related, but they are transitively dependent because of the category ID. So if you have that type of relationship, um, then if you want to convert in third normal form, then you break the relationship down. One thing I want you to understand is that um, this conforms to first and the second normal form. There are no multi-value attributes, and there are no non-key attributes that are not fully functional dependent upon the key attribute. This is a non-key attribute, and this is a key attribute, and this is a key attribute. It's actually dependent upon these two attributes. Um, so it satisfy the second normal form, um, and you may want to decide that you don't want to go any further, and it's absolutely fine for you. If you don't want to go down to the third normal form, then you don't really need to, or don't really have to. But if you do want to go down to the third normal form, then um, you need to find out the transitive functional dependencies and remove those. So subcategory ID is dependent upon product ID, but it's transitively dependent because of category ID. So if we break that relationship down, we will have a separate table with category and subcategory, and then we will have a table with product, category, and a price. Now, in my previous lecture, I actually discussed the disadvantages of normalization, and I also mentioned earlier that you may decide that you don't want to go down to the third normal form. And one of the reasons that you might have for not going down to the third normal form is the query performance, because um, um, the more joins you have in your query, um, longer it will take to actually retrieve data. Because if you look at this, what you are actually doing here is you're actually creating separate tables every time you're conforming to a normal form. And when you're creating separate tables, you're breaking your entities down into into separate tables. When you want to retrieve meaningful insight, so for example, if you want to know which products belong to which category, and what products were purchased by which customer, you actually have to join each of these tables to actually get an answer to your question. And that introduces more joins, and the more joins you have, longer your query will actually take. um, so that's the third normal form, and thank you very much for watching this, and I hope that you will find it useful. Thank you very much.